got it. So what I've got open right here is that same R Markdown that I worked with y'all on Wednesday with. And so the very first thing I'm going to do to load in all of the previous data that I've got, there's actually a bunch of ways you can do this. So instead of having to go like line by line by line and make sure that you're caught up, you can either press the run all, which will run all the lines of code. What I like to do when I'm starting a new code chunk is to use this button right here to the left of that play button. And what that does is run all of the codes above it. So it's just, I don't know, a preference, I guess, of how you want to do that. But what's important here is I don't necessarily need any of the data that we played around with yesterday, but we always want to make sure that we run that setup script, right? Or the chunks that we try to play with later aren't going to work. So I'm going to just comment on the top here, plotting with ggplot. And the very first plot I'm going to make is a scatter plot. I feel like that's a very common first go-to, trying to look at relationships between two continuous data sets, meaning both of the variables we want to explore are numbers. And that's called geom_point. And so the syntax for ggplot, regardless of what type of plot you want to make, it always starts with ggplot. And then if you're going to be performing a plot on like a single data set, you can feed the argument data into the ggplot at the top there, saying everything I'm creating is coming from this data set. So in our case, we want this plot to use data from penguins. And then this is a weird syntax thing that ggplot does, but instead of using a pipe, you use a plus sign to thread together multiple functions in the ggplot. Don't ask me why. It's very strange, but just something that a lot of people forget. Don't forget it's a plus sign when you're working with ggplots. So once you've told the ggplot what data set you want, next you want to tell it what kind of plot you want to create. So we're going to be creating a scatter plot, and ggplot calls that a geom point. Y'all, my brain is not working this morning. So geom point, almost all, if not every single one of the types of plot always start with that geom, and then the underscore, and then what you want it to be. So then another syntax thing here is you can't just directly feed it within the geom point what data you want to use. You have to actually wrap that in the argument mapping, which is just saying what values do you want to fill. And then within that mapping argument, this function AES, which stands for aesthetic. So within the aesthetic function, we're going to say, I don't know, what do we want to make a scatter plot of? Let's compare flipper length. So we'll have flipper length on the x-axis. And somebody help me, what's another column that we can do?
Mass.
Body mass, okay. So we'll do body mass on the y-axis. Do you want me to, and then when we perform that, it'll spit out a nice ggplot, very simple and basic. But voila. So I'm going to kind of gloss over all of the different ways that you can make this nice so that you have something to look forward to for next week when we really go into how to make these things beautiful. But there, as I said, a bunch of different ways in which you can make this kind of standard basic plot look really good. So the next kind of plot that is very handy as a data scientist is developing a histogram. So really just getting a distribution of a continuous value, seeing what's the most common, where is the mean falling, what are the max and min. So to do that, we use geom histogram. We're going to do the same thing where we're going to use our penguins data set. And then instead of geom point, we're going to use geom histogram. Our mapping argument is going to be filled with, here we're not using two different variables, we're going to use one. I want my histogram to fall on the x-axis, so it looks kind of like what you imagine. I believe you can actually set it to y, and it'll make a histogram that's like sideways. But let's do flipper length again. Cool. So clearly there is a bimodal distribution going on here. If I had to guess, I'm going to guess it's sex based on some of those summaries that we looked at previously where males tended to have bigger flipper lengths. In fact, this would be a cool one. Can you do color, Phil?
Mm-hmm.
I was wrong. So within the aesthetic, you can set certain other categories to be a particular color. And with a histogram, you're going to use the fill argument for that. So what that's doing now is actually splitting up our histogram into different categories and color coding them by said category. So I chose sex, and I was absolutely wrong. I bet it's actually islands.
Species.
Oh, right, there's different species now. I was thinking we were working with just Adelie, but we're working with all penguins. Okay, never mind.
Gen 2 are big boys.
But see, this is what's, it's the Gen 2. Yeah. Okay, so the next one I'm going to go over is geom bar for a bar plot. So this is getting a count of all of the different observations within a single island, meaning how many penguins there are that they were able to actually monitor. If you wanted to get the distribution within a single island of, let's say, the species, we're not going to be using y, because y is always a count in a geom bar. It's fill. So we're going to color code much like our histogram, and we're going to fill it by species. I got there. So with that said, we're going to now do a geom call. And that's when you have a categorical variable on the x-axis and then a continuous variable on the y-axis, right? So I'm going to do real quick a penguins modification. We're going to do another group by and summarize. I'm going to call this penguins average. And we did something like this last week, on Wednesday. But this time I'm going to group by island, just island. And then we're going to summarize. Here I'm going to call it average flipper length. And that's going to be equal to the mean, or the average, of the flipper lengths by island. So when we go to look at that new data frame, I forgot. What did I forget? Yes, okay. So we want to always set NA to true. It's kind of annoying that's not the built-in. It's kind of nice, though, if you don't do it, you realize there are some data observations that are missing it. But we want to get rid of those observations that are missing, and that's where we set NARM to true. So now we've got all of those averages across our islands. And then for our geom call now, we're not going to be using that unmodified penguins data frame, and instead this guy, we're going to continue to set our X to island, but here instead of the flipper length, it's going to be, oh, yeah, average flipper length. And then another just kind of handy little hack that I'm pretty sure occurs on a PC as well. If you like double click on any object in R, it will automatically highlight the whole thing. It's very nice if you need to copy and paste to make sure that you aren't misspelling things. The other thing that's nice about when you double click on something, it will also lightly highlight every other instance in your script that is using that same thing. So just a little handy aside. But okay, like this is my 5th attempt. Hopefully it'll work. There we go. So we can see that the island of Bisco has on average the longest flipper length.